Hello 8th graders. In this IXL video lesson we'll be taking a look at assignment I.3. Again, cluster I talks about proportional relationships and I.3 asks us to identify proportional relationships by making graphs. So as this is loading up on the screen, we'll reposition this out of the way. And we're going to bring some notes onto the screen as well. So I'm going to talk about these notes first, then we'll get into the problem. Again, we're focused here on proportional relationships. And the big thing we should already know about a proportional relationship is it's a relationship between two variables, so we measure how two quantities compare to each other. We usually use x and y for those two variables. And if it's a proportional relationship, it's any relationship where y and x's ratio, when you take y and divide it by x at any point, if it remains constant, then it's a simple proportional relationship. And if you do have a proportional relationship, when you put a proportional relationship, when you graph that situation out, it will always look like a straight line that passes right through the origin. This, of course, where my mouse is the origin, 0 and 0. And if I keep the same ratio of y to x, that requires me, I must have a straight line on a graph going through the origin. That's the only way it's possible to keep that same ratio all the time. So, in this situation, we're told we got to read through these word problems carefully, so I'm going to do that with you. It says Sean is determining the number of quarters equal to different dollar amounts. He finds that $1 is equal to 4 quarters, $2 is equal to 8 quarters, and we're told in this relationship x is the amount of money and y is the number of quarters, and graph the 2 points for this relationship. So here we're given 2 data points. The first data point is this one right here where we're told, hey, we'll put a little red box around this. It says $1 is equal to 4 quarters. So in red here, we need to graph the point. The bottom is dollars, x-axis left to right is dollars, y-axis is quarters. So I know my first data point, $1 is equal to 4 quarters. So on this graph, I'm going to find the 1 point for x, the 4 for y, and where I'm putting this red dot right now, right here, that's the point that represents $1 being equal to 4 quarters. Separately, and we'll put now a blue box around this, we're also given another data point. We're told $2 would be equivalent to 8 quarters. So I'll go to the $2 spot, I'll go to the 8 quarter spot on the y-axis, and right here, where I'm giving this blue dot, that's where I'm at $2 and 8 quarters. So go ahead and use IXL's tool here to actually plot those points. I'm going to click one point on the graph right here, click another point on the graph there, and you see when I do that, it creates a straight line that goes through those 2 data points. And we're asked about this graph. It says, according to the graph, do x and y have a proportional relationship? And if I see ultimately a graph that has a straight line that passes through the origin, that means y divided by x will always have the same ratio. 4 divided by 1 is 4 quarters for every dollar. Same thing for 8 divided by 2. And you all are probably saying, of course, it's always 4 quarters for every dollar, and that would never change. So that's the reason we have a proportional relationship here. We're going to graph a few more examples a bit more quickly this time around. So in the next problem, we'll read through the word problem. It says to make some extra money on the weekends, Kelsey drives for City Express ride-sharing service. During regular hours, passengers are charged a flat fee plus an additional fee per mile of the ride. A passenger who rides 4 miles in Kelsey's car is charged $6. I'm going to put a red box around that data point. And then we're also told a passenger who rides 8 miles is charged $10, and we're going to go ahead and put a blue box around that other data point. And they tell us in this relationship, x-axis is going to represent the miles, or the distance in miles, and the y-axis is going to represent the dollars that it costs the passenger. Graph 2 points for this relationship and the line passing through them. So here we know at 4 miles, Kelsey charged her rider $6. So I'm going to go ahead and find my first data point to plot. Is at 4 miles, we need a $6 data point. So this first point I just clicked here is from that red information. And then we also know for a different passenger who went 8 miles, they were charged $10. So I'm going to go to 8 miles, come on up to $10, and I'm going to click a point there. Now what I see is this straight line, it is a straight line. That means it's a constant rate for every extra mile. We keep adding the same dollar rate. But I also see something important here. This orange line that represents Kelsey's charges doesn't start at the origin. It starts at $2. And that's the key piece. Remember how they're charged a flat fee plus a fee per mile? So because they're charged $2 at the start, we don't begin at the origin, and there's just no way to have a proportional relationship if you don't start at 0 and 0. Y divided by X will keep giving you different ratios unless you start at 0 and 0, so that it climbs from both of them being at the same starting point as 0. So when I see this graph and I see it does not pass through the origin, I know there's a linear relationship, some constant rate of change, but ultimately we do not have a proportional relationship. Every proportional relationship would start at the origin. Another way to know this if it's proportional or not, if you do 6 divided by 4, you will not get the same ratio as when you do 10 divided by 8. We're going to skip ahead a little bit to a couple of the tougher problems in here just to give a sample of what some of the more difficult ones will look like. Okay, so for our next example, again, we're going to be given a word problem and have to create the graph to see if the scenario is a proportional relationship or not. We're told, fascinated by ocean life, Preston wants to put a saltwater aquarium in the bedroom. He needs to make sure he buys a big enough tank to grow his collection of fish over time. For 2 fish, Preston needs a 10-gallon tank. For 4 fish, he needs a 20-gallon tank. The next paragraph tells us in this relationship, x-axis here represents the number of fish, and then the y-axis represents the smallest size tank that Preston could buy if he wants to have that many fish. So we're going to go pick out the 2 key pieces of information here. We'll put the first one in a red box, and it says for 2 fish, Preston needs a 10-gallon tank. So it's broken up. We'll use 2 red boxes, 2 fish, 10-gallon tank, and then also we'll put in blue here, for 4 fish, he needs a 20-gallon tank. So that's our other key data point. I'm going to go ahead and graph those 2 points. 2 fish, Preston needs a 10-gallon tank, so find 2 fish on the x-axis, 10 gallons on the y. And this point here represents that red box. 2 fish will take 10 gallons. The other data point says at 4 fish we need 20 gallons. So at 4 fish we need 20 gallons. And what we're going to see, this is proportional, because 20 divided by 4 gives us 5 gallons for every 1 fish. 10 divided by 2 is also going to give us a ratio of 5 over 1. This has a constant 5-to-1 ratio, which is why we see the graph starting at the origin and then going in this straight line telling us it's proportional. I'm going to skip ahead to some of the challenge zone questions at this point. So get us up towards the 90 area just to see what does the toughest question or toughest question types look like. So here it looks like they'll give you larger numbers, but it looks like the problems throughout this assignment stay largely the same. I'm going to go ahead and get rid of my boxes and we'll read through some of these together. It says the Crane Company builds high-rise hotels in cities across the U.S. The hotels use the same floor plan, but the heights of the hotels vary from city to city. If a hotel has 30 floors, it will have 600 guest rooms. If it has 40 floors, it'll have 800 guest rooms. So we'll go ahead and graph those. The numbers are bigger now, but it's largely the same stuff. We will put into red first, I think. Yep, we'll use red first for 30 floors. Gives us 600 guest rooms. And then our other data point tells us if we have 40 floors, there's 800. So we'll go to this graph, 30 floors, 600 guest rooms, 30, 600, and we'll click that in here. And the other data point is 40 floors to 800 guest rooms, or 800 rooms for every 40 floors. And we see there again, this is a straight line that passes through the origin. If you did 600 divided by 30, you'd get 20 rooms for every 1 floor. Same thing if you did 800 divided by 40. Again, all of these are a ratio of 20 rooms for every 1 floor. That tells us this is proportional. At this point, I'm not going to keep going. This video has gone long enough. If you do need any help, as always, my email address is ddoherty3@bostonpublicschools.org. So I'll put that up here on the screen, ddoherty3. And that's, of course, going to be at bostonpublicschools.org. I'm just going to call that BPS. Thanks for watching to the end of the video. We hope this was helpful.